In our journey towards quality, we know that we have to measure what's happening in the process and try to improve the process. Look for opportunities for variation and try to map process variables to the product variables that come out. But there's this growing trend in organizations to think that measurement is expensive and measurement's hard to do and it's really difficult, and so we have to just focus on a few measurements, a couple of little measurements, and I'd like to sort of dispel that rumor. I got a chance to work with a large automobile manufacturer in Tennessee, and they were making polymer gas tanks. Now, rather than a metal gas tank or things like that, they were actually taking some sort of resins and making a polymer. It was interesting because it was 5-ply, so there was this big spigot in the roof that would spit out this polymer, and so there was a layer of plastic and another layer of some sort of space-age cloth that they had to keep everything all nifty, and then another layer of polymer inside that, and another layer of fabric, and then finally a 5th layer of polymer, and it all shot out of this tube, like I said, in the ceiling. And there was just giant, just huge molds that they would use to make these gas tanks. And it was, I don't know, it was as big as this room or something, and there were 4 different cavities for this, and each of the cavities would come under the hose every 15 seconds, and a shot of 5-ply polymer would come down, and they'd seal up the top and the bottom and shoot in all of the air and blow all of the polymer into the different corners of the mold and things like that, and then it'd shuttle out to the next cavity in order to cool off, and it'd shoot another one in the next cavity, and at the far end, the bottom had opened out, and these gas tanks would drop out. And there's a lot of opportunity then for things to go haywire, but there's also an opportunity to make sure that we could measure all of the variables involved. Certainly the product variables, the seams and the corners and the bumps and the holes in the gas tank and where it's supposed to be. But more importantly, we could also measure the process variables, the age of the polymers, the temperature of the polymer as it's being extruded and shot into the mold, the back pressure that blows it into the different corners, and actually even the tool wear, the age of the cavities themselves. Are all of the corners still sharp and well-formed and things like that, or after thousands and thousands of gas tanks, have those started to wear? And we would hook machines up to all of the programmable logic controllers that not only measured the dimensions of the gas tanks as they're formed, but also all of those different process variables. And on every single gas tank that we're making, 5-ply polymer gas tanks, every 15 seconds, day in, day out, 24 hours a day, we're taking 91 separate measurements after every gas tank. The data that we need to improve our process to determine the correlation between the process variables that we're measuring and the product results that we're trying to achieve are lying there within your process. What we need is to capture that data and apply the correct tools in order to make sure that we can separate out the signal that tells us when the process is doing well or starting to misbehave, and the noise when there's just random variation and things just fine. So in conclusion, there are so many different opportunities to make measurements on the products that we're making, the services that we're providing, that correlate to the process variables that in this 3rd millennium, 21st century world where everyone has 80 gigabytes of hard drive space on their desktop, there's no longer a good reason to not capture data. And thank you very much.